So f crosses the x-axis at negative 3 and 4, has a negative lead coefficient, and is a second-degree polynomial. So to graph this sentence, let's start with the easiest things first. What was the easiest thing to plot the zeros? So I'm going to go over here and plot a negative 3, 0, and a 0 at 4. So I know I have that. So it's going to look some sort of graph going through those two dots. Let's go next. What does a negative lead coefficient look like? Well, doesn't that mean my graph is going to be going down at the end? Okay. What does a second-degree polynomial mean? Isn't that even? Wouldn't that mean on the other end over here, isn't it going to go down as well with an even? So won't my graph look something like that? A negative lead coefficient and second degree means my graph will look something to that fashion. So through these two green dots, can we draw a graph that has these two end behaviors? It looks like a parabola. So let's draw a parabola. We're simply going to draw a parabola here. And then I'm going to label that f of x. Because we're going to graph two graphs, where this is f in green. I'm also going to be graphing g down here. All right, next part is right here. We're going to graph g using this table. So the first thing is, can we just plot these dots and then check these words later? So let's plot these dots over here. Here we go. Negative 4, negative 3. Negative 4, negative 3, we have a dot right there. Negative 2 zeros, a dot right there. 0, negative 4 is a dot right there. 2 zeros, a dot right there. And 4, 7 is a dot right there. Now, you can kind of see what it looks like, but we now need to verify exactly what goes through those dots. We have to read this. And it says g has no lead coefficient and is a third-degree polynomial. So if I say there's no lead coefficient, does that mean it's negative or positive? Well, if there's nothing there, isn't that probably a positive 1? If there's no lead coefficient, it's saying that your a is positive 1. That's what you're implying. There's no lead coefficient, there's a positive 1 hiding out there. And if it's a third degree, well, wouldn't a third degree with a positive 1 look like this on each side? A third degree with a positive a value will go up here and down on the other side. So this is what we're going to try to graph through these red dots. Okay. Now, do you see a bounce right here? Do you kind of see a bounce right there? It's going to come back down and back up. And this is g of x. So we have a bounce right there, and it has to come back up. Do you see how it goes up on the right and down on the left? Down on the left, up on the right. So everything for g makes sense. And for f, on the green one, everything makes sense. So our two graphs are sketches, but they follow all the details that are asked of them. The next part of the question is answering these three questions based on our graphs. Our graphs really help answer these. Without the graphs, you might really not understand how to these two questions until you graph them. The graph really, really helps. Which function has a negative in behavior as x approaches infinity? Now that x approaches infinity might confuse you, but what that's saying is as you go on the x-axis forever this way, which one has a negative in behavior? Meaning as you go this way, which one is dropping downward? Well, is it the green or the red? As you go this way. Well, can you tell the f, the green is dropping? It has a negative in behavior as x approaches infinity. So that first one is f of x. If I were to ask which ones have a negative in behavior as x approaches negative infinity, that would be this way. It would be both of them. As you go this way, don't both go down? But as you go this way, only the green F goes down. So that's what this question is basically trying to get at. Number 2, this is a little bit harder. On what interval do both functions have a positive value? Now, when I say positive value, I mean that means the graph is above the x-axis. Positive value means above the x-axis. So let's look at the green graph. Let's start with one graph and then compare it to the other. So if I look at the green graph, on what interval is the green graph positive? Well, isn't it from here to here? From -3 to 4, isn't my green graph above the x-axis? Is it anywhere else above the x-axis? No. It's only from -3 to 4 is this graph above the x-axis. So I know my interval has to be somewhere in here. But don't I want both of them having a values above the x-axis? So on both. So I know from here to here is the green. So within that interval, where is red also above the x-axis? Well, right here at -1, is red above or below the x-axis? It's below. How about at 0? Is red above or below the x-axis? It's below. When does the red finally cross the x-axis? At 2. Now from 2 to 4, right here, from 2 to 4, are both of the graphs above the x-axis? Yes. So for this little interval right here, both graphs are above the x-axis. Both graphs are positive. So I would call that the interval 2 to 4. Now why did I use parentheses instead of brackets? Because 2 and 4 are not above the x-axis. Only between 2 and 4. Okay, because they hit at those points. So this is the interval, not the coordinate, where both the red and the green are up here. So you got to focus on one and then look at the other. This can be hard for people to recognize. So, on what interval is g of x increasing at an average rate of change of 2? So we got the word increasing, average rate of change of 2. Now, isn't average rate of change really saying slope? So isn't this saying your slope is positive or -2? What's increasing mean? Doesn't increasing mean a positive 2? So what this question is really just saying is, where does m equal positive 2? Increasing at a slope of 2. That's all it's asking. Now, which function? G. So look carefully at G. That's the red one. And we got to look at it. Now, I could use the table or I could use the graph. I want to look on what interval between which dots is it growing as a slope of 2. So let's look at it one by one. Right here, from this dot to this dot, do I have a slope of 2? From here to here, I do not have a slope of 2. I have a rise of 3 over 2. Rise 3 over 2. That equals 1.5. That is not 2. So that's not the interval. Let's go to the next one. Well, this is a drop of 4 over 2. 4 over 2 is 2, but isn't that negative? Isn't that going down 2? So I can't include that one, because I'm looking for an increase. All right, this dot. I'm going up 4 over 2. What's 4 over 2? Oh, it's 2. Is that what we're looking for? A slope of 2? Did I go up 4 over 2? That equals 2, and that's what we're looking for. So what's that interval? What's this interval right here? It is 0 to 2. So from 0 to 2, my average rate of change is 2. Now, could I check to make sure the last one doesn't? Let's see. This last interval is going up 7 over 2. Up 7 over 2 is not 2. It's 3.5. So we know this interval right here is where I have a positive increasing of 2. Right here, I had a -2 slope, which is a decreasing of 2. So be very careful. Average rate of change of slope, you're just looking one by one to see if the slopes are 2. positive too. Graphing really, really makes you able to answer these. Without the graphs, you'd probably be lost.